In eukaryotic cells, DNA, of course, is located in the nucleus. The first step for DNA extraction is to break open or lyse the cell. Several methods of cell lysis are available. You may freeze the cell or boil the cell, or use chemicals that break up lipid membranes. Whatever method is used, the lysis buffer typically also includes a DNase inhibitor, which prevents any cellular DNase protein from degrading your DNA sample. With the cell lysed, there is typically a lot of cell debris, and the DNA is swimming around in the liquid portion of the sample. If you then centrifuge the sample, the cell debris is heavy and will form a pellet at the bottom of the tube. DNA is not heavy enough at tabletop centrifuge speeds to be pressed down with the rest of the debris, so the DNA is in the top liquid portion. The liquid is referred to as the supernatant. You can transfer the supernatant from the tube to a clean tube and be free from the cellular debris. If you have salt in the supernatant, you may add alcohol to the DNA sample and the DNA will clump together or form a precipitate. The DNA will no longer be dissolved in the liquid, and the chunks of DNA can now be centrifuged to form a pellet at the bottom of the tube. You then pour this supernatant off of the DNA pellet and allow the ethanol and other residual liquids to dry. DNA is very water soluble, so you can add water to the dried DNA pellet and it will dissolve. Now you have DNA in solution, and you can analyze the DNA in the sample to determine the amount of DNA you extracted and to determine how pure the sample is.